Some outages come from huge deploys. Some come from breaking changes. But the most dangerous ones are the ones that come from innocent looking tiny updates. Hey guys, this is Kalpesh. Welcome to the Let's Crack IT. Today, I'm going to break down how one harmless looking change triggered a full blown code red in a tier 1 production system. This is not a theory. This is a kind of incident that happens in real enterprise environment every year. So let's break it down. Let me set the scene properly. We were running a GK regional cluster across 3 zones, the backbone of the mission critical system. This meant multi-zone control plane, multi-node pool layout, and the most importantly, a strong 99.95 monthly availability SLO. This was a tier 1 service, the kind where every minute of the downtime directly affected revenue. Now here's where the thing started. Team were working on node pool upgrade, a routine but critical maintenance activity needed for security patching, CVE updates. But after a node pool upgrade, GK did something predictable because autoscaler delay timers are conservative to avoid sudden scaling fluctuations. And engineers noticed that after the upgrade, old unpatched nodes remained alive for 10 to 15 minutes. New nodes were up and ready, but not fully utilized. So someone on the platform team with the good intention said, let's tune the autoscaler. So the old nodes drain faster and we want traffic fully shifted onto the patch nodes since the maintenance window was about to end. It made sense. It looked safe. And they made this tiny change of reducing scale down delay times and rolled it out into the production. The mistake they did here is they did not roll back the scale down delay times and system went live into the normal operations. And then the lights begin to flicker. When traffic dipped, part of the normal daily curve, the autoscaler reacted instantly. Old nodes were gone. Pods running on these nodes evicted super fast. Instead of the usual gentle spaced out node drain, it triggered a rapid aggressive eviction event. Now here's where Kubernetes mechanics take over. We had important workloads that use pod anti-affinity topology spread constraints. So when a node drained the autoscaler, scheduler had to find room for pods in specific zones, following rule that restrict placement. Suddenly, dozens of pods trying to move across zones simultaneously. This wasn't a rolling reschedule, this was a storm. It was a tier 3 system architecture where Redis was the shared infrastructure component on which entire backend system was relied on. Each pod used Redis for user session lookup, token validation. What happened here when 20 to 30 pods rescheduled at once, each of those pods tried to initialize all Redis clients, reestablish all required connection, warm up the internal caches. This created a massive burst of new TCP connections. Redis hits its max client limit almost instantly. And when Redis rejects connection, here's what happened. Readiness profile, pods go unready, traffic drops, Kubernetes restarts pod, restarting pods reconnect to the Redis rejects it again, and we had just entered a self-amplifying failure loop, which is called as a Dominic effect. And then the autoscaler made it worse. The autoscaler saw pending pods, high CPU on remaining nodes, pod flapping, latency spike, and assumed the cluster needed more capacity. So it added new nodes, which scheduled new pods, which immediately tried to open a new Redis connection, which then Redis rejected. At this point, the system wasn't just failing, it was accelerating its own failure. Then the incident manager opened the save one. Leadership joined the call. On-call SRE joined the call. Redis team were notified. Application team pulled in. Then the incident commander said the words nobody wanted to hear, declaring the code red. And in that moment, everything else just stopped. All project work paused. All changes frozen. All teams laser focused on the recovery. This is the code red, guys. Dashboards are red everywhere. Slack or Teams are just exploding. Business stakeholders are demanding ETA. Engineers have 10,002 minutes. You are trying to talk. Also listening, typing, monitoring, making decisions simultaneously. And this is the pressure. But you know what is the most important thing during the code red? Is being calm and thinking quietly by eliminating all the external noise. And that's how you become successful. So once we understood the pattern, node drains, pod eviction, Redis meltdown, pod restarts, more node drain, we knew we had to break the cycle. So we recovered the system in a layered one control step at a time. So very first thing what we do, roll back the autoscaler change. What we did, stop the source of the chaos. We reverted the autoscaler timers back to the original safer defaults. So no aggressive draining, no fast scale downs, no instant node removal. This immediately slowed down the rate at which the pods were being evicted. It didn't fix everything, but at least it stopped the bleeding. Then second step we did, Redis capacity bump. Redis was choking, Max client was fully saturated. New connections were getting rejected. So we quickly increased the memory store tier and set the proper connection pooling, which automatically expanded memory, increased connection capacity, reduced the eviction pressure. It gave the Redis a breathing room. This was like opening the oxygen valve during a fire. As soon as Redis had more capacity, pods finally started connecting again. Third step, what we did, controlled pod restarts, not the blind cluster restart. Here's the tricky part. If you let Kubernetes handle it automatically, it will restart too many pods at once, cause another reconnection storm, overload the Redis, restarted the pods small intentional waves. 5 pods, wait, 5 more pods, then wait, monitor Redis, continue. This prevented the thundering herd of the reconnections and allowed Redis to stabilize gradually instead of being hit by the 300 connections attempt at once. Uh, then first step we did, pause further node training. We froze further node termination, no more eviction storms, no more rescheduling bursts, no more surprises from the autoscaler behavior. And this locked the cluster in a stable topology. So we could heal it without fighting against the Kubernetes. Then slowly, very slowly, the graph started to shift. Redis latency dropped back to the normal ranges. Connection rejection stopped. Pods moved from unready to ready to stable. Error rates started failing. Throughput climbed. Then autoscaler calmed down. And most importantly, CPU and memory curve flat. Is that the moment every SRE knows when the noise in the call reduces? Everyone stops talking over each other, and you finally see the system coming back to the life. Once ready stabilized, and all pods stayed ready for several minutes, and our synthetic checks passed consistently, the incident commander said, "We are downgrading the code rate." Traffic normalized, SLO burn stopped, the system was healthy again, and the incident was officially closed. But the lessons from it, those stayed with us. The outage wasn't caused by autoscaler alone. It was caused by a combination of factors. Reasonable config change applied at the wrong time, missing PDBs, no strict connection pooling, no retry back off, Redis Max client was too low, pod anti-affinity forcing large reschedules, production pod counts much higher than the staging. Distributed system rarely fail from one thing. They fail from the interconnections. Now let's talk about the reliability. Our SLO was 99.95% of monthly availability. That means monthly time 43,000 minutes, allowed downtime 21.6 minutes, and our outage lasted for almost 45 minutes end to end. That means we burned 200% of our monthly error budget. Our SLO was irreversibly broken to the month. All future launches got blocked. Leadership reviewed the trigger. Reliability KPI were reset. Extra security for every change after that. In code red situation, SLI drops instantly. Error budget burns uncontrollably. The entire month's reliability promises breaks. And here's the truth. SLO don't pause because you're under pressure. SLIs don't stop measuring because it was just a small change. The system records everything. This incident taught us a hard but important lesson. In production system, there is no thing as a harmless change, especially not in the autoscaling, which is the heart of the cluster stability. After this, we hardened autoscaler setting, added pod distribution budget, implemented strict Redis pooling, uh, switched autoscaling to the custom metric, added node drain chaos test, improved the observability around the pod eviction and Redis connection. That was the important part. As SRE, our job is not to avoid code reds. Our job is to learn from them, build guardrails, and prevent the next one. This is KD, and together, let's crack.